me and giving the opportunity to give you a little insight on what we are doing and how we use Kamailio in that sense. Today I will talk about our mission-critical network deployments, and even though public emergency calls are not the major use case in our solutions, customer now and then demand public emergency calls to be delivered to PSAP. So we heard from Wolfgang already today a bit about the public safety in the public network. And yeah, let me go briefly through the agenda. So just in a nutshell, 2 words about what Kontron is doing. Then again, to recap what is mission critical, because it has some kind of definitions, what's behind mission critical. Then the building blocks of the architecture we are using. So you will see all the applications and nodes we are running. We can run in different deployment models, either in public cloud environment, but 99% we are on-premise in either Kubernetes cluster or any other virtualized environment. And then we dig into the use cases and features, what we finally did for the emergency calls, for the public emergency calls. And also an outlook, what we have on our radar for the new features for these emergency functionalities. And last but not least, the Q&A, if there is time left. Otherwise, I'm here, and you can ask afterwards as well. Yeah, what is Kontron? In one sentence, Kontron is delivering end-to-end solution for mission-critical networks. Our main customer base is railway organizations. Nevertheless, we have also here and there public transport organization using our solution. And a few words about myself. I'm part of Generation X. I'm doing this telco development for more than 20 years. Started with GSM for railways, what is still in place. So it's 2G-based technology, and a few years back, we have started with IMS and Mission Critical Push-to-Talk, which is the voice service for Mission Critical. So the overall terminology is MCX, and I like DevOps. Okay, let's start. What is Mission Critical? So it's basically must be available wherever and when needed. The probability of failures and the frequency of failures must be very low. So we have to fulfill the 5x9, for instance, and the system works reliable end-to-end. You will see in another slide what's behind this, and it must be secure in regards of integrity and confidentiality. A few mission-critical functions. Wolfgang mentioned them also in his talk in one or the other slide. So voice is the MCPTT part with optional push-to-talk. What does it mean? A user has actively pushing a button to get the floor. The floor is basically the uplink that he is authorized to talk, and only one user can talk at a time. That's the push-to-talk. That's optional for private calls, point-to-point calls. Then we have the group communication, where it's mandatorily to push to talk. We have extremely fast call setup time requirements. We are using preemptions and priorities within the network. On the one hand internally, but we also have to use interfaces towards the access networks like RX or N5 interfaces. The data communication is the MC data part of the MCX, and we have also the MC video, which is also for private and group calls. And finally, we have also the interconnectivity with other systems. This is also a very important part also within this talk, which finally enables the communication from MCPTT towards other domains like public network, voice over IP, or GSM-R networks. A few highlights, what I see mission critical versus commercial network. In mission critical, you have the radio coverage there where needed. Let's say when you consider railway customers, you need the BTS, so the base stations along the track. While for public or commercial networks, you require the radio where more in the urban regions where more population is there. We have users in mission critical few, while in public we have many. For instance, I don't know out of my head, but I think our biggest customer hosts only 100,000 users, while in public you have millions of users. Encryption authentication is used on both sides, as well commercial as mission critical. As said before, priorities preemption is very important topic. And finally, yeah, commercial public operators rely on billing to earn money, while in mission critical networks, in principle, the system is used for operational purpose. Nevertheless, we also use billing interfaces, but this is more for statistical purposes. So we are using, for instance, an RF interface towards a charging gateway function when we talk about IMS terminology. And also very important, what makes a system mission critical? It's not only one network component. So finally, it's a chain where all the components must fulfill the mission critical requirements. This includes the devices. Of course, it depends then on the customer needs, but some of our customers demand ruggedized devices. Of course, they have to support this push-to-talk functionality. Same for the applications. The application must support all the features, functionalities I explained beforehand. And the network. So, and if one of the pieces in the chain is not considered as mission critical, the whole system is per se not a full mission critical system. Okay, now a brief look. This is just an example how we use it. But overall, it's the architecture we use in each and every deployment. So it's based on 3GPP IMS 23228. And it also shows where we use Kamailio. So also mentioned by Ramona, we use it for PCSCF, ICSCF, and S-CSCF, all the various modules. We have also a dedicated module developed, which we use for interworking with Rayleigh domains. We will also publish this soon. Due to time constraints, we didn't so far. It includes a few conversion functions and specific functionality we basically require to interwork with our major customer base, the railway market. The next slide shows more or less the same, but it shows the interfaces we use. So the IC interface towards the application server. The application server is hosting the service, the mission critical push-to-talk service. We use the IC interface. So again, this is 3GPP standard. We do not use a full-blown IMS. We just use the pieces and parts what we require. We have the diameter interface switched between I and S-CSCF and our HSS, the home subscriber server. Home subscriber server is a built-in application by us and hosts the SIP IMS subscribers for authentication and all the services. We use the CDP modules for the diameter. What else? Yeah, one demand of the customers is to do voice recording as well, and for that purpose we use RTP engine and SIP trace modules towards our RTP proxy, which is also acting as a black box recorder then finally, but this is a third-party vendor we've integrated with our PCSCF based on Kamailio modules. Yeah, let's jump into the use cases and the scenarios for the emergency calls and to be precise, to the public emergency calls. In mission critical networks, the same for GSM-R, there are per se emergency calls like railway emergency calls, which are then handled within the network itself, or some customers, even when you dial a public emergency number like 112 or national ones like 133 in Austria, 144 for the ambulance in Austria, they are then routed to the so-called dispatcher within the mission critical network. Nevertheless, we have the demand and obligation from some customers to route such calls like 112 through the public network finally to the PSAP center. What we did in that regards, again, this is a sample now where we interconnect directly with a public operator. Of course, we have also the other option, which you see at the later slide, that we connect to our GSM-R customers if the PSUB is still, or the public operator is still on the GSM-R network. So either the public operator already moved to the next generation MCPTT network, or if it's still on the railway network, then we have to interconnect and interwork with GSM-R. What we did, we introduced an SBC, a session border controller, in regards to fulfill security. We host our PCSCF on this SBC node. The SBC is acting as a back-to-back user agent in our solution for several reasons, like topology hiding or other security features we have to implement. Then we have this interworking function, which is spread over 3 of our nodes. And we implemented this in Kamailio on the S-CSCF and I-CSCF. And we have also parts running on our application server. And in this example, you see we are directly connected to the PLMN, to a public operator. And what we do, even though our IMS, our solution is based on IMS architecture, we mimic a PBX. That's why we call it emulated PBX, which basically registers from the CSCF through the SBC towards the public operator. We get a dedicated, I don't know the correct term, head number for addressing our network, and that's why we call it emulated PBX. Yeah, and we use hash tables. You will see also a few examples later on to store information, configuration, and also do dedicated transformation functionalities which we require. This is just showing the other picture on which nodes in our solution we are running emulated PBX functionalities. So the most important is the I-CSCF, because this one has the trunk towards our SBC. All the registrations towards the public network is initiated by the I-CSCF, as well as incoming, outgoing calls. So SIP invites are passing through the I-CSCF. So why we have also some functionalities on the S-CSCF is simply as we have there already functions like address mapping, which means we have to address internal MCPTT towards dialable or public E164 numbers. But finally, important, all the messages are passing through the SBC, which you see on the next one, that all the messages, SIP messages, are passing through our ISBC towards the public operators network. Yeah, this is just an example, and what we've done, we have also, for instance, implemented some CAM commands to check the state or do various things. In the sample below, you just can check the registration state using CAM command, and a value 5, for instance, a value 5 indicates that the network is registered successfully. We also have some watchdogs running and perform alarming towards our network management system. Okay, then the journey started with some simple things. So what we have? We have on our phones. So we have an MCPTT Android app, or we also support iOS recently. And finally, you can perform emergency calls, which are treated as simple or plain private call as any other private call. So we do not have anything specific. The only specific we have is our IWF, because in MCPTT you have additional payload on top in XML bodies on top of SIP, and the IWF also does some transformation and additional header manipulation. That's why we have to pass through the IWF before leaving our network towards the public network, and the public network finally takes care about delivering the call to the PSUB. But again, this is nothing specific, and our solution relies, of course, on data connectivity. Can be 4G, 5G, private or or public if we run over the top, but let's assume there is no 4G, 5G coverage, then our application does a fallback onto 2G and uses the native UE to perform the 1112 call towards the public network. So these were the initial steps. We have fulfilled that our customer at least can do something in regards of this. And so we were then basically thinking, okay, how to improve things. And we introduced the so-called emergency function. We also call it lightweight ESCSCF, so emergency CSCF, because it's simply not fulfilling all the standard requirements. What it does, basically, it detects emergency calls by a request URI. It performs a mapping from the PANI header. The PANI header is the peer access network info header, which tells the IMS, besides the access technology, also location information. So that means that the originating user will be routed to the correct PSUP. And the PSUP is this public safety answering point, is basically a physical location where the emergency call from the public is received. Wolfgang knows for sure better, but in a nutshell, I think that's it. Finally, we map this information, and the emergency function also is then responsible for routing the call and forwarding additional information, such location information from the UE. Like our MCPTT users, for instance, if they are fixed terminals, like a dispatcher, can then also send the geographical address along towards the destination. And we are also able to handle callbacks, but again, this is also just a lightweight solution because we rely here really on the public network, and that's why we at the moment bind to a specific operator always. We have to test if it works properly. Where was it implemented? We implemented it on the S-CSCF as kind of extension of the IWF. Why? For several reasons. The IWF itself already has the capability to modify, manipulate all these headers. We can do address mapping quite easily, and it's already establishing interworking from out of the box towards our other domains. That's why we simply put it as an extension on top. That means whenever you run an emergency function, then you require the IWF enabled as well. Okay. This is the use case now I was mentioning previously. Let's assume we have a customer which has a GSM-R network, still running the trains with 2G technology. However, already users are migrated to the MCPTT network, because the goal is that the MCPTT network should replace the GSM-R network, but potentially this will take for sure 10 years from now still. But let's assume you have already users on the MCPTT domain, but the public operator network and their PSUP behind is still on the railway domain connected. Then the user on the next-gen MCPTT network initiates the call. It passes the PCSCF, which is hosted on our SPC, and goes through ECSCF I/S-CSCF towards the MGCF. The MGCF is just the media gateway control function, a part of the GSM-R network. So in principle, this is representing the railway domain, and this is the public domain. And this is schematically then depicted here with the red arrow. The red arrow is the signaling flow, S-CSCF, IWF, and ECSCF. And you see the ECSCF detects the emergency call based on the request URI. It maps the PANI header to the PSUP URI. Finally, it will be then routed to the PSUP through the S/ICSCF. And in this case, we have to remove the geolocation header, because at the moment the GSM-R cannot handle it. So it would throw just error or info logs. Yeah, and the blue one is just the RT base stream. And the IWF itself does also a few things. A part of this header and body manipulation, it adds additional information like a user header towards GSM-R, because in railway networks you do not call with phone numbers. You have roles. Let's assume a train is running today from Munich to Frankfurt. It's the train number 123, and tomorrow another train runs from Munich to Frankfurt, and it's also 123, but there is the hardware, so the train itself is a different one. So that's also transported between the networks, this information. And this is the use case when the PSUB or the public network is already moved from GSM-R to the MCPTT network side. Then the user initiates. Again, we go through the PCSCF, acting as an access SBC. E-CSCF, along with IWF, will be passed. We go through the interconnect SBC, and we leave our network towards the public operators network. The E-CSCF again detects the emergency call, maps the PANI header, and routes it, and does also this header manipulation. In this way, in this case, we do not remove this geolocation header, which includes the location information of the calling user. Yeah, the callback from PSUB, let's assume you do an emergency call, but then the call gets dropped, then the PSUB must be able to call back. Again, this relies on particular operators, so it's not working out of the box. Nevertheless, in our deployments with our existing customers, we have found the operators supporting this, and we can call back, and we detect it also on the E-CSCF, in this case based on some priority information. And IWF then towards the originating user does again these manipulations. That's it from the scenarios. So maybe a few features that we can highlight how we do it. So again, in this example, what we talked about before, the E-CSCF detects based on the request URI. We configure this in hash tables, that the emergency function treats this call as emergency call. If emergency call is then detected, the E-CSCF does all the extensions and inserts the IWF into the flow. The PANI header information, the PANI header, we have kind of proprietary layout defined, and we have two models. On the one hand, a location ID as an integer, on the other hand, a location ID carrying an IP address. Why is that? Because sometimes, specifically for non-MCPTT users, so for VoIP users, we do not receive any of this location information we would require. So we basically identify the correct PSUB based on IP subnets, and because we have deployed our VoIP users then per regions. And this is what we have currently defined. And so the incoming call will have this pAccess network info with a location ID 42. And again, in the hash tables, we define then a URI for the outgoing side. In this case, it's the 4350255, whatever. And you see then on the outgoing side, the request URI includes this PSUB. And yeah, we have this transformation functions, IP to PSUB or location ID to PSUB, depending on the terminal. And if, in case there is no location ID configured or misconfigured, we have also a default PSUB, which will be used in that case. So that's it, what we have today. Still, some improvements we have and ideas we have on our list. on the one hand, we do not fully support redundancy towards the external zip trunk. So we do support kind of redundancy, but it depends on a few factors. So this is two things we have to improve for the ICSCF towards GSM-R and towards the external zip trunk towards the public network. We will extend the interworking towards the railway domain, including also the geolocation info, that even if the PSAP is behind the railway network, that the information is being transported. But this is only applicable to German market, because there is a specific Notrufverordnung telling how to deal with it on the railway side. And yeah, we do currently not support if the originating user is not IMS registered. So this is also what we want to support, emergency calls without the registration. That means the PCSF already detects the call as a public emergency call and will then directly send it towards ECSCF rather than the S-CSCF. And also we might support, but this is on the access side, I think more the IMS emergency registration. Then we have a dedicated bearer or emergency bearer can be used. That's it, what I wanted to tell you. I hope it was a bit interesting. So thanks for your attention, and yeah, feel free for any questions.
Thank you, Roman. A question coming from Vienna.
Thanks for the presentation. One or two questions perhaps. First one is, if you're removing the geolocation header and you're just providing the PANI or network ID, how does the PSAP know about the location? Can the PSAP also map this identifier to a certain location, or? Yes, so on the problematic, when we go, because we remove it only when we go to the railway side, right? Because today on the railway side you have this information you have anyway only from the mobiles, because you can then send the cell and the cell of the originating user. If you have today a dispatcher, you will not send it to the public network and the PSAP. So and that's what I was saying. At the moment, there is this neue Notrufverordnung only in Germany, where you can also then transport via the UUI extensions postal addresses. And then we can send this information, the geolocation information, and the GSM-R will transparently forward it to the public. But today, it's also not possible. Okay, and only for mobiles, right? For mobiles, it's possible, but also only from the granularity, only on the cell. Also, what we improve now is that we give each cell, we give GPS locations. This will also be coming okay, soon. That leads to the second question. So if you get this accurate location from the device, would you also use it to map to the most appropriate PSAP instead of mapping your cell ID just using the geolocation? Yes. Yes. But again, that's not that's not available today, but that's in development, let's say.
Okay, one more question from here, and then they have to catch you outside.
In one of your slides, there was this registration handling Kamailio config snippet, and you had something like CSEP wraparound logic. Can you?
Sorry, say again.
In your Kamailio example, there was this CSEC header wraparound logic.
Okay.
Can you discuss why that is needed, and if it's not done, is it a public safety hazard?
This I have to look up. It's quite old, but we can look later. Okay.
Yep. Thanks.
Okay, that's getting deep into the SIP. Now let's move on, because we need to search on the RFC. Okay, thank you, Roman.